Hello everyone, welcome to A-Level webinar series organized by Mission Kadoba of Muslim Majlis of University of Sri Jayawardhanapura. As scheduled, today we will be having the integration recap session for the brothers and sisters who will be sitting for the A-Level examination in English medium mathematics stream. Before moving into the session, a kind reminder for the participants who join us today. Please be kind enough to keep your mics muted to avoid any inconveniences. And at the end of the session, we will give you the chance to ask questions. So you could unmute your mics and ask your doubts, or else you can drop a message via chat box. And also, please refrain from drawing on screen while screen sharing is ongoing. So, this warm welcome is for Abdul Hakim, graduate of University of Sri Jayawardhanapura, to continue the program.
So, good evening, everyone. Hope you all are safe. And today we are going to do a session on integration. So, before coming into integration, what is integration and why are we using it? So, there are a lot of practical applications of integration. You can find the volume, the area under the curve, and even the image, even the screen you're looking at is probably filtered using integration because image processing uses integration. But most important for you guys, so when you take about A-levels, the 15th question of the A-level paper is on integration. And also the first part, also you get a question on integration. So before, so we'll be doing a recap on integration. So we'll be looking at not an in-depth session, but on all the topics you need to know about integration, we'll be doing a recap. So if you guys have any questions, please unmute and ask, no problem. I'll put it in the chat. That's okay. So before starting, so can someone tell me what is integration? Or before integration, let's start with what is differentiation. Anyone wants to tell what is differentiation? All right, so I hope you can see my screen. So the first thing you need, what is differentiation? A simple explanation is the rate of change. For example, imagine you have you're driving a car, and you're speeding, you're pressing the accelerator, and the car is speeding. So it increases its velocity at a constant value. So what is the acceleration, or what is the rate of change of distance, or rate of change of velocity? So that is acceleration. So how do you get the rate of change? You get the tangent, right? You get 2 points, and you get delta y, delta x, and delta x y by delta x gives you the tangent, or the rate of change of velocity, that is acceleration. Now, but what if we had not a constant acceleration, but a change in acceleration? So if I wanted to get the acceleration at this particular point, if I drew two points and got the acceleration as the tangent, that would be wrong, right? Because we don't get the exact position at this particular point. So what we can do is make this delta x value so small that it comes exactly at this point. And we get, instead of the tangent at, instead of the gradient at any point, gradient at one single point, this exact point. So how do we do this? We make x so small that we can get this point. So that is why we call it dy by dx, or in other words, differentiation. So if you differentiate it at this particular point, you can get what is the acceleration or the rate of change. So if, for example, dy by dx is equal to 2x, so when x is equal to 1, you can get the rate of change, and x is equal to 2, you just have to substitute and get the change. So that's differentiation. What's integration? Well, integration, you can think of integration is in mainly I said three ways. Number one, you can think of integration as the opposite of differentiation. For example, I just said if x is if y is equal to x squared and we differentiate it, we would get 2x. Derivative of 2x by x squared is 2x. Since integration of 2x with respect to x is actually x squared. So if we differentiate x squared, we get 2x. If we integrate 2x, we get x squared. So you can think of integration as the opposite of differentiation or an antiderivative. And another way you can think of is as the summation. So imagine you have a curve and you want to get the area under the curve. I want to get the area of this curve from here to here. So what I do is I take a very small piece of this curve and I get the area of that particular region only. So let's call this, let's say this as delta x and this whole distance as y. This is small like in the screenshot. Yeah. So what is the area of this? Delta y or y times delta x. Y times delta x. That is the area of this particular curve. Now I want to get the area of this whole thing. So I want to get, let's say this particular place is A and this is B. I want to get from A to B. So how do we do this? We take all the small pieces of areas and we add them up together from A to B until we get the entire area. And that's why we call that integration is a summation. We add a lot of parts. For example, here we can say, can take y. Now it's dx. Why do I put dx? Because this delta x value, when we make it very small, we call it dx. And we integrate it from A to B. So this would give you the area for this particular curve. So that's why we call integration as the summation. Small parts, you can take it and add them all together and you get the entire thing. The area in this case, or you can get the volume in different cases. So as you want, you can do. So if you think of differentiation as the rate of change, you can think of integration as the summation of things. So any questions? Just a small introduction before starting. If you guys have any questions, please ask. You can unmute your mic and ask, or you can put it in the chat. Like, do you understand? If you don't understand us, hope you all guys have done integration. So this is basically a recap because we can't go in depth through all this stuff. So we'll do a basic recap of all the things you need to know, right? Okay, no questions. Right. So you can see my screen, I think. Let's look at a recap of integration. Now, right. So if you look at integration, there are many parts of integration. So there are just a few parts that you need to know. The first part you need to use, these are, I took this from the teacher's guide. So these are the different parts of integration you need to know. So first of all, we need to get the integrals using antiderivatives. So you know differentiation. If you differentiate this comes. So using that we can get, if you integrate this, we can get the derivative integral. And then we look at some of the properties of integration. And using trigonometric identities, how can we solve integration problems? And then we look at definite integrals, that is when there's a limit, as you saw in the area thing. If there's a limit on the integration, how do we solve that? And then let's look at some of the standard methods of integration. And we'll look at integration by substitution and integration by parts. And we'll look at the area under the curve. And finally, how do you get the volume of revolution using integration? So these are the main different parts that you need to know about integration when it comes to A-level. So the way we'll be doing this is we'll just go on a recap on all these different topics, and after that we'll be doing questions on past papers, right, on integration. So the first thing I told you was that we can think of integration as antiderivative, right? So for example, if we have x to the power n plus 1, if you differentiate this, with respect to x, you will get, what will you get? What will you get? To the n plus 1 different x and subtract 1 from this n. That's the result of differentiating x to the power n plus 1. So if I wanted to get the integration of x to the power n, this one, right? So all I need to do is do the reverse differentiation or the antiderivative. And there's an extra n plus 1 term, so I need to divide it by that. So the integration of x to the power n with respect to x can be written as x to the power n plus 1 divided by n plus 1. So where did we get this? From differentiation. So when you differentiate this, we know we get this. That means when you integrate this, we get this. So likewise, we can have if you know differentiation of different properties, we can have the different antiderivative or the integral of all those properties. So these are some examples. So if you remember, this is the one we just saw, x to the power n. If we integrate it, we get x to the power n plus 1 divided by n plus 1. Okay, I forgot to see. What is c? Now, initially I said when we differentiate x squared, we get 2x. So that means when you integrate 2x, you get x squared. But what if you differentiate x squared plus 1? You'll get 2x. How come? Because the derivative of a constant is 0. What if I differentiate x squared plus 2? It's still 2x. So can I directly say that the integration of 2x is just x squared? It could be x squared, it could be x squared plus 1, plus 2, or any other constant. So that's why when we differentiate, if it's an indefinite integral, what is an indefinite integral? This integration sign has no limits. So it just says integration. So you need to put something called c. C is just a constant. That it could be 1, 2, 3, and write within the brackets that c is an arbitrary constant. So if you forget this sometimes, they might reduce marks. So always when you're integrating indefinite integrals, remember to put the c. So if you know differentiation, you know that if you differentiate ln x, you will get 1 over x. That means if you integrate 1 over x, you should get ln x plus c. Remember the c for all this. So if you differentiate e to the power x, you get e to the power x. Same way, if you integrate it, you will get e to the power x. If you differentiate sine x, you get cos x, and same reverse, you get if you integrate cos x, sine x. Now the minus here comes because if you differentiate cos x, you get minus sine x. That means if you integrate sine x, you get minus cos x. So similarly, like these are the different derivatives if you can remember from differentiation. So the differentiating cot x would be cosec x, and so on. So and this also you must remember. So sine inverse x over a. If you differentiate, we get dx over a squared minus x squared. Now the thing here is we need to first make it in this form. If it's in the form of a squared minus x squared, we'll look at this form a bit later. But if you have this in a squared minus x squared form, remember you can write it as sine inverse x over a. And what is the differentiation of tan x? tan x over a is actually a over a squared plus x squared. So if you have in this form a squared plus x squared, you can write it as the integration as tan inverse x over a, and because there's an extra a, you can divide it by a. So do you guys understand? Like, I don't want keep talking to myself or anything. So if you want if you have any questions, please ask. If you don't understand, please say. Like, do you guys understand this? Like, can you just if you can't speak, try to raise your hand or something? Okay, right. You do it, right? So let's move on. So this is the first thing I said. Integration as antiderivatives. Now let's look at the next part. What are the properties of integration? So mainly we have two properties. If we have a constant multiplied by a function, we can take that constant outside. So if we have, for example, so the property is this: if we have fx, fx is just, what is fx? Just a function of x, right? So it's multiplied by a constant, that is c. When you differentiate with respect to x, we can take the c out, the constant out, and write fx dx. So for example, if you have 4 cos x integrating with respect to x, we can, instead of just, now do we know the integration of cos x, 4 cos x? But we do know the integration of cos x, right? So because this is a constant, we can take it out. 4 cos x dx. And now we know the integration of cos x, so we can write it as 4 sin x plus c. C is an arbitrary constant. So this is the first property. And the other property is, so if we have two functions, fx and gx, fx, gx, and we integrate the whole thing with respect to x, we can write this as integration fx with respect to x plus integration of gx with respect to x. Similarly, if it's minus fx minus gx, we can write it as fx dx minus gx dx. Right? For example, we have this e to the power x plus cos x minus sec x tan x, and we integrate the whole thing with respect to x. Now we don't know the differentiation of this whole term, right? But we do know the differentiation of some of the single terms, right? So we know the differentiation of e to the power x. We know this, and we know this. So what we can do is separate this according to the theorem. Integration cos x with respect to x minus sec x tan x with respect to x. So what is the integration of this? We know that e to the power x, if you differentiate it, you get e to the power x, which means if you integrate it, you still get e to the power x. Cos x, we just did it, sin x. What is the integration of sec x tan x? If you integrate, if you differentiate sec x, you'll get sec x tan x, which means the integration of this is sec x. Remember the c. This is an arbitrary constant. So you can use this theorem to break down differentiation equations into smaller ones so that you can integrate them separately. Right? Now, those are the two properties I told you. Now, there are just two more things, sort of like shortcuts or extra things I'll say. So if fx, the integration of fx is equal to let's say another function of x, let's call it phi x. Sorry, this is respect x, okay. Then the integration of f ax plus b, that is x is multiplied by a constant and something else. So we can write this as phi, the same thing. Instead of x, we substitute ax plus b itself. And because there's an a in front, we divide it by a. Now, this might sound a bit not familiar, but if you do an example, it will be clear. So if you integrate, for example, cos x. What is the integration of cos x? Sin x, right? Plus 2. What is the integration of cos 2x plus 3? Same thing. Now look at this. If this is cos x, integration of cos x is a certain thing, the only thing you need to do is substitute the same thing, ax plus b, and divide it by the constant. That is sin 2x plus 3 divided by the constant. Sorry, not the constant, the coefficient of x, half. Now this, the easy way to do this is consider this whole thing as x, right? Now what is the integration of cos whatever is sine, right? So this is, so I'll get the same answer again. So if we integrate this, put sine whatever that is inside, think of this whole thing as x. So sine 2x plus 3. Now think about the differentiation. If I differentiate this, I'll get sine 2x plus 3. If I differentiate, I'll get cos 2x plus 3. And then what happens? The chain rule, remember? What is inside, you differentiate it. What do you get when you differentiate 2x plus 3? You get 2. So the 3 becomes 0 because it's a constant, and you get 2. So we need to cancel this 2. That means you need to divide it by 2. So first think of the whole thing as x and integrate it, and look at what are the extra terms that are coming and cancel it off. So you get the same answer, sine 2x plus 3, and remember the same. And another thing that would be very important to remember is this. So if we have now, if you have fx, that's a function, and if you differentiate the first derivative, you can write it as f dash x. Right? This is the first derivative of the differentiation of fx. Right? So if we have the derivative of that particular function on top of this function, this is also an important thing you need to remember. You can easily put this as, and you just differentiate with respect to x. It's ln fx. How does that come? This is modulus, okay? Ln modulus fx. How does that come? Try and differentiate. If you differentiate this, you'll get 1 over whatever is inside here. Sorry about that. So share it again. Right. So if you differentiate fx, you get 1 over fx. And then what do? You differentiate what is inside. That is f dash x. The derivative of fx is f dash x. This is the same thing you got here. So if you have the derivative of a function on top of that function, remember you can always write it as ln fx. Right? So those are some of the properties that you might need to remember. So let's move on. Next, let's look at integration using trigonometry. So you can use the somehow the trigonometry theory that you know in order to come up with integrals. So we already did the first two, right? You know that sin x, the differentiation, so cos x derivative is sin x. So the inverse is like this. Now look at the tan x one. So how do we get the different derivative, sorry, integration of tan x? In using trigonometry, how can we write tan x? So tan x can be written as sin x over cos x. Tan x can be written as sin x over cos x. So integration of tan x dx can be written as integration of sin x over cos x dx. Now look at the what I just said. If you have the derivative of something on top of that, you can write it as ln f dash x fx. So is the derivative of what is the denominator? Cos x. So what is the derivative of cos x? Minus sin x. So is that on top? Well, something like that is on top. Can we make it minus sin x? Yes, we can. Is that the minus? Because there's a minus. Take it off. Minus and the minus becomes plus. So you can just write the answer as ln cos x. Because there's a minus. And right? Now, if you were looking very carefully, you will see that actually what was here was ln sec x. Oh, I got ln cos x. This is ln sec x. Is that a mistake? No, it's not. Because what we got was minus ln cos x. So minus ln, whatever, if you have a log, if you take the minus inside, it becomes to the power, right? Cos to the power minus x minus 1, which means 1 over cos x. What is 1 over cos x? Sec x, the same thing. So if you got sec x, how do you differentiate this, integrate this? What you do is, no, it's sec x over 1, right? The denominator is 1. You multiply. No, I'm not going to do everything, single thing, because it will take time. I'll just say overall what we do. So you get an idea, right? So you multiply both the numerator and the denominator by this value, tan x plus sec x. So what you get on top is sec squared x plus sec x tan x. What you get on bottom is tan x plus sec x. If we differentiate this, what is the derivative of tan x? Sec squared x. What is the derivative of sec x? Sec x tan x. That's what on top here. So which means the entire integration of this is ln tan x plus sec x. Now, if you're asked to do an integration of sine squared x or cos squared x, the first thing you need to do is convert them into cos 2x terms first. So we know cos 2x can be written as 1 minus 2 sine squared x or 2 cos squared x minus 1. So depending on that, so if they're asking to integrate, say, sine squared x, first thing you do is replace that with cos 2x. How do you replace that? Sine squared x, if you take to the other side, you can see that sine squared x can be written as 1 minus cos 2x divided by 2. So using that, so 1 minus cos 2x, right, divided by 2. So that is half times 1 minus cos 2x. Now we can integrate it, right? Because you know the cost, the derivative of cos, integration of 1 is x. The integration of cos 2x is sine 2x minus. So sorry, plus sine 2x. And what is sine 2x? Sine x cos x. So whenever you have sine squared x or cos squared x terms, first of all, them into cos 2x terms and then do the integration. Okay? And when you have sine cube x or cos cube x, first of all, convert them into sine 3x and cos 3x terms. So from integration, from trigonometry, you must remember these equations. Sine 3x can be written as 3 sine x minus 4 sine cube x, and cos 3x similarly can be written like this. So when you have cubes, take the cubes to one side and make it as, see, 3 sine x minus sine 3x, divide the whole thing by 4. So first of all, convert cos cube x and sine cube x terms into these terms and then integrate, because that's much easier. right? So those are the basic things we need to know about trigonometric identities. So how do you get the integration using trigonometric identities? Right? So next, let's move on to something called integration by substitution. Now, if you have a sum, if they ask to integrate something, you can, instead of integrating that, you can have a substitution, and then this should make it easier for you to actually integrate the things. So these are some of the standard substitutions they have given. So for example, if you have sine to the power m x, where m is an odd positive integer, instead of this, you make the substitution t equals cos x. So I'll do an example later so you can understand. So similarly, for all these are standard substitution. So if you have anything in this form, a squared plus x squared, x equals a tan theta. So these are substitutions you can make so that it will be much easier for you to integrate it because it comes in a standard form. So when these are something you need to remember. So substitutions, you need to remember, like if it's in this form, the substitution I may need to make is this. If it's in this form, the substitution need to make is this. So these are some things you need to remember so that you can apply them wherever it's needed, right? I'll do an example of one. So look at this one, dx over px plus q, ax plus b. Right? So as I said, these are some of the substitutions you need to remember. Whenever you have this form, you need to remember this is the substitution I wanted to make. For example, let's say you have an example for dx over x plus 2 times root x plus 3. So what that is in this particular form. So what is the substitution that they say they need to make? T equals ax plus b. Now you don't have to remember ax plus b or whatever. This is basically whatever is within this root. So what was the example I said? X plus dx over x plus 3, 2 into root x plus 3. So what is the substitution here? X plus 3 is equal to t. Now you don't just have to make a substitution. You can't just put substitution and then do ahead. What you need to do first is, okay, t is equal to root x plus 3. Then you need to differentiate it. So not only are you going to substitute the ax plus b terms with t, but you also need to substitute the dx. Remember, we are differentiating with respect to x, right? So now we have not x, but t. So we need to get the differentiation in terms of t. That means you, first of all, whenever you make a substitution, let's differentiate that with respect to whatever the symbol you're substituting. So for example, in this case, what we are doing is we are telling it's equal to t, right? So you differentiate the whole thing with respect to t, and then you get a value for what x or dx, and you need to substitute that value in place of dx so that you can actually use the substitution. So let's see. So this is the question. Right, this is the question I was talking about. X plus 2 root x plus 3. So you saw from the substitution list, what is the substitution we need to make? Whatever within the root should be equal to t. So t is equal to root. So substitution is equal to root x plus 3. Now what do? You differentiate this with respect to t. So what is the differentiation of this? So first of all, this is obviously because we are differentiating with respect to t. So how do you differentiate something with respect to something else? You first differentiate it with respect to x, and then you use dx by dt, the chain rule, if you remember. So if you differentiate this, what is the value? Differentiate it with respect to x, 1 over 2 root x plus 3 into 1. Right? And then you differentiate the whole thing with respect to t, that is dt by, sorry, dx by dt. Now, what is dx? So dx can be written as twice root x plus 3 times dt. So what is, now can we actually substitute this? We can't, right? Because this has both x and both t. So what we need to do is we need to have the t as part of x as well. So what is x in the case? So that's why I said we can't just substitute. We need to make sure it's in a particular form. So now there's another way of doing this. Instead of initially substituting, what you can do is here t is equal to x minus 3. So easy way to do is you can remove the square before substitute differentiate. So t square can be written as x minus 3. Right? So now if you differentiate, it will be much more easier. And you can differentiate with respect to t. So that is 2t. So shall I differentiate this? It will become 2t. What is x? If I differentiate with respect to x is 1 into dx by dt. Minus 3 will go up. That means simply we can say that dx is equal to 2t dt. This is a much more easier way of substituting. Now I know what is x. Sorry, I know what is dx. What is x? So from this we can say x is equal to t square minus 3. Sorry, plus 3. Right? Okay, let's move on to the question. Question was dx by x plus 2 into root x plus. Okay, sorry, it was x plus 3. So it's plus 3 here, plus 3 here. This is minus 3. So now I'm going to substitute, but wherever there's dx, I put dx equals 2t dt. Right? Now we're substituting with respect to t. And what is here? So what is x? Sorry, we got x plus 2. What is x? X is equal to 3 square plus 3 minus 3. So x square plus x plus 2 is add plus 2 to this. That means t square minus 3 plus 2 is minus 1. This is x plus 2. What is x root x plus 3? That's just what we substitute, right? We said that whole thing is equal to t. Right? Now t cancels off. Now how do we substitute this? We can think of this as 2. We can take 2 out because of the first theorem. Now look at this. What is this? T squared minus 1 can be written as difference between two squares. T minus 1 into t plus 1. And what is the way that you integrate something like this? You need to first, I'll talk about this in the next session as well, but next lesson as well. But now here what we do is we turn it into partial fractions. We basically break this down. So we can make this as 2 t minus 1 and t plus 1. So if I put 1 and 1, t plus 1 and t minus 1, it will be plus 2, right? So I'm going to divide the whole thing by half. So 1, 1 minus. So t plus 1, it will be t plus 1. Then t minus 1, minus becomes minus 1, plus 1 becomes minus 1 into minus becomes plus 1, 1 plus 1 becomes 2. So to cancel that, I put a half in the middle. Because this is 2 now, we can separate it as this. Half can be written as 4. Right? So now we know what is t minus 1. The derivative of t minus 1, 1. Derivative of t plus 1, 1. That means that's what's on top of the this thing. So we can say this whole thing is 2 cancels off ln t minus 1 minus ln t plus 1. Now don't keep the answer like this. What did they initially ask you to differentiate? This one, right? Dx, so integrate this one, dx over x plus 2, x plus 3. You differentiated the whole thing and came up with this one, right? But this is in terms of t. So always substitute the value, particular values you got for x in this particular value. So the answer, the final answer would be ln. This is because ln minus ln, you can use it as what do you call it? Dividing. So t minus 1 over t plus 1, right? What is t? T is equal to root x plus 3 minus 1 divided by root x plus 3 t plus 1. The whole thing modulus value of 3. So this is the final answer. Sorry, I'm writing on that. So what did we do? We had dx x plus 2 x plus 3. Now what is the possible substitution we can make? So when you looked at the integration, what we saw here, we saw that this is in this form, and substitution then they have asked to make is whatever in the root, make that equal to t. So that's what we did. So first we made it equal to t, substitution, and then we got the derivative of that, and we got dx in terms of t. Then we used substitution and integrated it. And then finally, for that substitution, we added what was the thing. For example, we got t here. Instead of t, we put x plus 3. And finally, got the answer. Right. So that's about integration by substitution. So these are some things you need to remember. Next, we'll go have a look at integration by parts. So this is the only equation you need to remember when it's integration by parts. U dv by dx can be written as uv minus v du by dx. What the hell does this mean? So before applying, so easy way, it's very easy to get this equation. So if you know the chain rule from differentiation, if you have uv and you differentiate it, you get first of all one of this into the derivative of the other, v into du by dx, then plus the other one into the derivative of the other, u into dv by dx. So if you integrate the whole thing, so integration of this, the d by dx goes off, uv comes this, and then when you mix up the terms, you get this equation. U into dv by dx is equal to uv v du by dx. Might seem very, what the hell is this kind of equation, but it is simple to do it into it. So let's do an example. So what's the u dv by dx is equal to uv minus integration v du by dx. So it's basically you have something and you have the derivative of something. So whenever you are given a question and you are say asked to find solution by integration by parts, what you need to do is you need to check if these two, can we make these two out of what they have given. So an example we can look at is x e to the power x dx. So we have one, we have another one. So this is a product. Now we need to figure out what is u and what is av by dx. Now if you differentiate x, you'll get 1, right? If you differentiate this, it will be the same thing. If you integrate x, it will get x squared over 2. If you integrate it, it will be the same. But so it seems if you can differentiate this, that means it will be x becomes 1, so it will cancel off. So that will be easier, right? So we can, so what are we doing here? Look at first differentiating. Du, right? Du by dx, u. So we can select this as u, and this as dv by dx. So let's see if it's correct. So what do they say? If you have something in this form, you can write it as this. So here, what is u? U is x. dv by dx is e to the power x. So what is x? Sorry, what is v? To the power x plus c is not necessary in this case. We'll put it at the end. So if you differentiate e to the power x, it will be the same thing, right? So u into v. What is u? X. What is v? E to the power x. This one. And then what is minus? What is v again? E to the power x. What is du by dx? U is x. What is the derivative of u? Derivative of x, 1 into 1 dx. This is their respective to x, we are integrating. So x e to the power x. Now we know the integration of this, right? E to the power x, the same thing. E to the power x plus c. See? That's it. Now the important thing about integration by parts is how do you select these two? So imagine I selected, say I had the same thing, e to the power x, and instead of doing this, I said this was dv by dx, and this was u. So let's see what happens. So then x would be, this is uv, right? What is u? E to the power x, v is x squared over 2 minus, what is v? V is x squared over 2 into u, e to the power x dx. Now look at this. I have something that is a much more complicated integral than what I started with. I started with x e to the power x. Now it's x squared e to the power x. So it's making it more difficult, right? So whenever you got that, you just have to change the u and v dv by dx and do it, and you get the answer. So important thing is how to select u and how to select dv by dx. So that's all you need to know about integration by parts. Right. Next, we'll move on. Any questions? Please ask. Right. So now let's look at some of the standard methods of integration. Now, these are like some sort of like tips, like if it's in this form, this is what you need to do. If it's in that form, this is what you need to do. So if you sort of know this stuff, whenever they give a question in that particular format, you can understand this is the way I need to consider. So I'll explain that like this. So there are, I'd say, these are not necessarily maybe not taught like this, but to it as 5 different methods. Okay, you can see that. So the first thing is, first standard method is this. So if you have a integration, sorry, integral that they have given in this format, a cos x plus b sin x over c cos x plus d sin x. So both the cos plus sine, the coefficients are different. So if you have this case, what you need to do is you need to write the numerator, that means the top one, in terms of the denominator, lambda times the denominator, and mu times the derivative of the denominator. What you're going to do is, instead of writing the top one, you're going to write the top one in terms of the denominator and the derivative of the denominator. So how do you do that? Let's take an example. Cos x plus 2 sin x, cos x plus sin x. So what I'm trying to do is we're trying to make the numerator, that means cos x plus 2 sin x is equal to lambda times. So lambda is this constant. The 1, 2, 3 is a constant, right? Cos x, what is this? The denominator. Cos x plus sin x, and the derivative of the denominator. Minus sin, what's the derivative of minus cos x? Minus sin x, derivative of sin x, cos x. And if you compare the coefficients and stuff, you will find that lambda is equal to 3 over 2 and mu is equal to minus 1 over 2. And then you can write this in terms of that. So instead of the numerator, what I'm going to do is I'm writing 3 over 2, that is lambda, times cos x plus sin x as the denominator, plus this is mu into the derivative of the denominator. Now, why did I write it all in this particular format? Now you say this is the denominator and the denominator, right? These two can be cancelled off. So we have only dx. And here we have the derivative of the denominator divided by the denominator. Reminds you of something. F dash x divided by fx. So now what is simple? Just we know that the derivative of this, that is x, and then the derivative of this is ln the denominator. What is inside? Plus an arbitrary constant. So this is the first thing I want to say. So if you have an integration in this format, a cos x plus b sin x divided by c cos x plus d sin x, this format, what you need to do is try to write the numerator in terms of the denominator and the derivative of the denominator, and then substitute those values, and then you get something in this format. So just have a integrate this, and then ln the other value. So you get, because it's in the format, f dash x divided by fx. Right. So that's the first thing. Going a little fast here. So if you have any questions, please ask. So the next method you need to remember is this. So if you have ax plus b divided by cx plus d form. So both are in terms of x. What you need to do is very similar to what we did before. We are trying to write the denominator in terms of the, sorry, we are trying to write the numerator in terms of the denominator. So instead of 2x plus 5, we will write 3x minus 2. So you can see it's kind of 3x minus 2. So, and using that, I'm trying to make 2x plus 5. So it's 3x, right? But it's 2x here. So how do you do that? You divide it by 3 and multiply by 2. But if you do that, then the minus 2 is also there, right? So 2 times minus 2 over 3 minus 2 would give you 4 over 3. So that's an extra minus 1. So I add that 4 over 3 here. What is remaining is the 5. So what I did basically was I tried to write the numerator in terms of the denominator. Now you can see because it's the denominators and the numerators are same, we can just cancel this and get dx here. And the next is just a constant, right? That is, in this case, we got 19 over 3. Right? Now, if we go here, we get 3x minus 2. What is the derivative? It's 3. So I put 3 on top. And because I put 3 on top, I cancel 3 as well here. And then when you differentiate, we get the correct answer. 2 over 3x plus ln 19 over 9 ln 3x minus 2. So when you have something in this format, ax plus b over cx plus d format, what you need to do is try to make the numerator in the form of the denominator and then mm, uh, simplify it and you get this particular answer. So like these are some methods like when you get and when you read the question and you get it in this format, so you can turn it into this format using these particular methods, right? And the next one is, now this is very important. Standard method number 3. So if you have integration in this format, dx divided by a square plus bx plus c. If you have it in this format, sorry, so if you have in this format, there could be 3 different scenarios. Delta or the discriminant, that is b squared minus 4ac, could be less than 0, sorry, could be greater than 0, equal to 0, or less than 0. Now, whenever you have it in this format, first of all, look, is the discriminant greater than 0, less than 0, or equal to 0? And depending on that, you can change it or do the integration so that you can get the answer. So first of all, if it's greater than 2, then it is greater than 0. What do you mean by the discriminant greater than 0? It means that particular equation has roots, real roots, right? It means it can be written as factors. So for example, so what you should do whenever that is the case, you need to break it into partial fractions and then consider the integration. So here you get x plus 1, x plus 3. It's very small, you can see. So we can break it into x plus 1 minus x plus 3, the integration, and then the integration. So we did the similar question just a while before. So whenever you have it in this format, you have ax square plus bx plus c, and the discriminant is greater than 0, always turn it into partial fractions, right? And the next thing is when it's equal to 0. What do you mean by a root being equal to 0? It means it's a perfect square, right? So whenever you have a perfect square, because you know 1 over x, if you differentiate minus 1 over x square. Similarly, we can use that form here. So if we have dx over a perfect square, that is b square minus 4ac is equal to 0 type of perfect square. And because it's a perfect square, we can write it as integration of that as minus 1 over x plus whatever that is. Right? So we have minus x plus minus 2, sorry, dx over x minus 2, the perfect square. We can write it as minus 1 over x minus 2. So when the b squared minus a over c or the discriminant value is 0, use it in, you do this method. Okay? And the last case is when b squared minus 4ac value is less than 0. That means there are no real roots. In that case, what you need to do is we need to get it into the tan inverse integral form. But tan inverse, right? So if we differentiate tan inverse, you get a over 1 over a square. Let's give an example, right? So whenever you have this, right? So when you have, for example, in this case, the example is dx over x square plus 2x plus 2. So if you look at the discriminant, that is b square minus 4, you will see that is less than 0. The two squares, one is 1 into 4 is 4. So 4 minus 4 is 4 minus 8 is minus 4. That is less than to 0. So what do you need to do is we need to consider it in the tan inverse form. Remember when you differentiate tan inverse x over a, you'll get something over x squared plus a squared, right? So try to write that in that form. X plus 1, the perfect square plus 1 squared. So then the differentiation of that, so the integration of that would be tan inverse x plus 1 over 1, and because it's the top is 1, we can divide it by 1 because it's a over a square plus x square, right? So a in this case is 1, so we need to divide by 1. So hope that was clear. So there are three things we need to remember here. uh, when it's in the form dx over ax square plus bx plus c, it could either be, the discriminant could be less than 0, equal to 0, or greater than 0. So if it's greater than 0, what you need to do is you need to break it into partial fractions. If it's equal to 0, turn it into perfect square, that is 1 over x square terms, and then integrate it because my 1 over x, the differentiation of 1 over x is 1 over minus 1 over x square. So because it's in that form, you can make it that. Whenever the delta or the discriminant is less than 0, convert it into a form of 1 something over a square plus b square, a square plus x square. That is the tan inverse derivative form. And then you can use the integration as tan inverse. Okay. Any questions? So the next method, so that's most standard method number 3. So two more methods. So now first we talked about dx over ax square plus bx plus c format, right? So what if what, you have a question? Alright. So what if the denominator was a root? So x over ax squared plus bx plus c is the root of that. So in if a is less than 0, and this is a we have a particular popular format. So remember this. So if a is less than 0 and the delta value is greater than 0, what we need to do is we need to get it into the sine inverse integral form, right? So in this example, you can see it's dx over 3 minus 2x minus x squared, right? So this can be written as, okay, I forgot the root here, 2 square minus x plus 1 square. How would I write that? So remember the 2x minus x square, I'm going to complete the square. So how do you complete it? First, I'll take the minus out. That means you have 2x plus x or x plus 2. So you have x plus half the value of the coefficient of x, that is x plus 1, and the perfect square. So x plus 1 perfect square, if you square it, you get x squared plus 2x. That's what we need. And then you get an extra plus 1 multiplied by minus becomes minus 1. So you need to add that. So you had 3 here. If you add 1 to 3, that is 4. And it becomes 4 is 2 squared, right? Form dx a squared minus x squared form. Dx over root a squared minus x squared form, which is the derivative format of sine inverse x. Okay. So we can directly say that the integration of that is sine inverse. So that is the fourth standard method. And the final thing we need to know, final method. So today also something that's found in many past papers. If it's in the same format, the root was there in the denominator, but in the top there was a px plus q. There was a term of x. So if you have this particular value thing, what you need to do is first of all convert it in a way that you can get it to the standard format method number 4. That is something nothing on top, but the root on bottom. So this before. So x plus 1, the example you can see is x plus 1 over 5 plus 2 minus x squared. So first you need to know, first thing you need to do when you have something like this, there's something on top, if something fx plus some x plus 1, something on top, and you have a root x square plus bx plus c format on the bottom. The first thing you need to do is you need to differentiate the denominator. Differentiate root 5 plus 2x minus x squared, the one you see in black. Okay. So what do you get when you differentiate this? Get 1 over 2 root, whatever that is, and whatever you have inside, and into the derivative of what is inside. So 5 plus 2x minus x squared, derivative of that is 2 minus, because it's 2x becomes 2, minus x squared becomes minus 2x. So finally you get 2 minus 2x over if you simplify it, you get 1 minus x over root 5 plus 2x minus x squared. Sorry, the screen is a bit lagging. So what did we do? We took the derivative of the denominator and we found a value. And now what we are trying to do is we are going to make the what we have, but the question they have given, we're trying to make the denominator, sorry, the numerator of that as the numerator of the one we just found. Screen is right? Right. So the top what we got here is 1 minus x. So we are trying to make 1 minus x as the numerator on the question we have, and then make it the numerator we got. So 1 minus x, to make it x plus 1, you multiply it by 1 and add 2. Now when you differentiate that, sorry, when you get to the next, they have two values. One is the same thing we got by differentiating numerator, and the other one is in the format that we did before. There is nothing on top, but we have a root value on bottom. So for the first thing, we can use that because we know that the differentiation of this is this. We can use the integration is the same thing. The the denominator itself. And for the second one, we have uh, a minus x squared. That is the integration of that is sine inverse, right? So we can use that as 2 sine inverse. So the last two methods are similar. If you have something divided by the root of ax squared plus bx plus c format, where a is less than 0, a is negative, and the delta is positive. So what you need to do is you need to make it in sine inverse terms. But if it's not in that form, that means if the numerator had a ax plus b format, so what you need to do is first of all differentiate the denominator and get a certain value on the numerator of that, and try to make the question that have been given according to that, and then you get two parts. One is the exact same derivative of the one we just did, so we can use that, and the other is the same format as what we got before, standard method number 4, that is interesting. That's how you do. Those are the 5 standard methods. Like, these are not things you need to like remember itself, but these are when you know this format. Okay, when I get a question in this format, what do I need to do? That's pretty. When you see a question, okay, this is the format the question is in, so this is what I need to do. These are. It's better if you can remember all this. Right. So next we'll move on to definite integrals. So when we talk about integration, we all this time we talked about, which means there was no limit on the integration. But here we are considering a limit, as you can see, a to b. What this means is, so if you have fx, right, the derivative of fx is 5x. Sorry, the integration of fx is 5x. The integration of fx from a to b is actually 5x from a to b, where you instead of x, what you do is you insert a and b. So it will be 5b minus 5a. For example, you have an integration sine x from 0 to 5. 5 is the value 5. So then if you differentiate it, you'll get minus cos x, right? But remember the limit a to b. So instead of sine x itself, for x you substitute 5 and 0. So it is cos 5 minus cos 0. So that will be the final answer. So in indefinite integrals, you need to remember there is no plus c. The arbitrary constant that we added will not come here. So some of the different properties of this we need to remember is if you have the integration and if you have the integration of fx from a to b, we can write the same thing as minus fx a to b, minus fx, but now we can flip the two limits, not from a to b, but b to a. That's one important thing you need to remember. And the second one is the same thing as what we taught before, right? It's fx. If you have a constant, you can remove the constant outside the integration sign. And the third one is also the things we consider the same thing we considered before. So if it's fx plus b g extent or fx plus or minus g extent, we can write it as fx plus gx terms and say the limit is the same. Now the next one is a bit important. So look at this. So it says that the limit is from a to b. This can be written as the same thing, fx dx, a to c, and c to b. When c is, what is c? C is a value in between a and b. Now this is a very important thing that you might be able to use in different scenarios. For example, if they are asking you to integrate from the values, say 0 to 5, 5 in the sense 2 5 r 5. So if you want to integrate that, but you don't know the different integration of those, you can actually change the limit. Instead of going from 0 to 5, you can go from 0 to 5 by 2. And in the next integral, you can use 5 by 2 to 5. So instead of 0 to 5, you can use the same thing as fx 0 to 5 by 2 and plus fx 5 by 2 to 5. So in these scenarios, you can use this sort of terms so that it will be easier for you to do. And the next item that we need to do is the last one. And that's also a very important thing we need to remember, that if you have fx from 0 to a, you can write the same thing, the same limit. The limit does not change. It's still fx 0 to a. But what changes is what is value inside. You, instead of x, wherever you have x, you substitute a minus x. Right? So that will give you the same answer as before. And that is something you know, because that's also something that's very important. Right. Next, we move on to the area under the curve. So there are just two more topics remaining. One is the area under the curve, and the other is the volume. Said before, you can think of the area as the summation of small parts, right? So that is what we're doing with integration. We're dividing the whole area into small parts, and we are getting the summation of all those parts. So if now that's why we need definite integrals. So here we give a limit. We give a limit saying it's from here to there. So for example, in this case, you can see there's a curve that is going from 0 to x, right? And the x increases. But what if we needed the area between x squared, sorry, between a and b? So what we do is we integrate fx, we get the integration, but now we're going to integrate it and say the limit is from a to b. Now, whenever you put a limit on this thing, you don't get x at the end, right? Because you saw it before. We substitute values by x, right? So if you get final value, you get as x, like let's say 2x, let's say x squared. So the final value would be x squared, and then you get the limits, right? Let's say it's from 1 to 2. That means x squared from limit 1 to 2 means you substitute the high value first, that is 2 squared minus 1 square. So that would give the area in terms of, it will give a not an x value, right? It will give an actual number. That's why we can use it to get the area. So which is an actual number. So that's what we do. So if we have to get the area in between two curves, sorry, area under the curve in between 2 points, simple thing to do is get the integration of that area and apply the limits from where you want to A to B. And if you want to get the area bounded by two curves, so for example, in this case, we see fx and we say gx. Fx is the top part and gx is the bottom part. So the area bounded by the curve, what is this area? If you look at this, you can think and look and think that what is the area under fx? The entire area, right? What is the area under gx? The area that is in white, this particular area. So what is the area bounded? The area bounded is the area under this minus this particular area under gx, right? So this whole thing is integration of fx minus the integration of gx. And where do we want it from? From a to b. So if you want the area bounded by two curves, simple thing to do, the top curve, take it, subtract the bottom curve, gx, fx minus gx, and then integrate it from the a to b. The where you want it to be. This will give you the area in the curve. And the final thing we'll look at is the volume of revolution. So this is something I think from the new syllabus. Okay. So how do you get volume of revolution? Now, what the hell is a volume of revolution? Before thinking of it in terms of this, let's move the camera. camera seems to be a bit laggy. So if you have, let's say, just a, one point in the fx, sorry, xy item, and what you need to do is, what if you rotate that line? So, so think of this line, and what if you rotate this line about the x-axis? So I'm rotating this line about the x-axis, which would give you a circle, right? Can you see this? I'm rotating this particular line. This is the line. I'm rotating that around the x-axis. It's the same line that is rotating around the x-axis. So what do I get? A circle. What is the radius of that circle? The length or the height of this line, right? So that is the area. Now, what if I want to get the volume? Now, remember how do we get the area? Is one small part of the curve, and then one small part of the area, and then we integrate it because we got the sum for all the values, all from A to B. The same thing we're going to do here. We're going to take a small volume first in this case, and then we're going to take a small volume and we're going to integrate the whole thing from A to B. So I have the screen is separate. A circle. Now, what is the area of the circle? Pi r square, right? What is r? Fx is r, right? So that area of that circle is 5 fx square. And to be part, this area is 5ax 5 x square, right? And we are going to integrate the whole thing from A to B. So the entire volume of this uh, thing will be 5 fx, the fx square dx from A to B, right? So the entire volume would be 5 times fx square. So because 5 is a constant, we can take it out. So it will be AB 5 fx square. Yes. Right. This is the only new find the volume. So whatever they ask, when they ask for the volume, they will give you the equation of the line. That is, give me a single part. It is A and B. So all you will do is use this equation 5 times fx square A to B, right? And integrate. So those are the different 10 or 9 topics that you need to know when it comes to integration for A levels. So that's basically a recap on all the different parts. The questions to pass through the questions from the past papers. But my the screen is a bit lagging, so I'm not sure if you can properly see it. Sorry for that. There's a small connection issue. So I was going to do the questions, but instead I'll just do a few questions so that it will be easy because, right. So the first question comes from the 2016 past paper, right? So if you look at this, is integration dx over 3 plus root 3 plus 2x. Told about the standard methods. If you remember one of those, you can see what is the thing you need to use. So it's in the form of something over root ax square plus bx plus c, where x is in the negative form. Remember the last or the last two standard methods we discussed, the 4 and the 5. So that's what we need to do here. So if you remember, what we did was, if we have it in this format, dx over this format, what do you need? So this can be written as dx over. So x minus x square, you can write it simply as x minus 1, the perfect square. So we get x square, we get minus 2x, right? And then we also get an extra minus 1. So we need to add that, that is 2, that makes it 2 square. Over the So now this is simply sine inverse x minus 1 because it's a definite integral, indefinite integral, we need to add c. So I think my screen is a bit lagging. So I think it will be better if I recorded this separately and uploaded it. So this video will be uploaded, I hope, for the YouTube. So we can upload 2 questions today, but that's okay because I think it will be difficult to understand if we are doing with the screen lagging and all this stuff. So, so that you can see it in a minute. So I'll just briefly recap of what we did today so that we can go. We look at integration. So there are different parts of integration using derivatives, integration properties, trigonometric identities, definite integrals, that is where the limits, and we discover we area and volume of revolution. So these were some of the things because we know the differentiation, we got the integration, and when they talked about certain properties. So if there was a constant, we could take the constant out. And then if you have separate them into two different ways. Using trigonometric identities, we can further do integration. So if you have sine 2x or cos 2x terms, convert it in sine squared or cos squared terms, convert it into cos 2x first. Similarly, sine cube and cos cube, convert it into cos 3x terms or sine 2x terms. And then we talked about integral substitution. So there are different standard substitutions. Say x equals 8 tan theta, and then differentiate that and get the value of dx, it should be d theta. And instead of x, it should be whatever the substitution we make. And then integrate. That's integration by substitution. So integration by parts, what you need to do is you have two things. You have u as formula. So whatever that comes here should be much easier to simplify than this. So using this formula, you can do integration by parts. And then we discussed about 5 different standard methods of integration. We talked about the different where we had A and B, the limits of A and B. So what you need to do is when you get the answer itself, instead of linear 5x, substitute B, the upper limit first, and subtract that from the lower limit. Last two. So you can from A to B can be written as A to C and C to B. the limit can be changed. Now, so if the limit is the same, you can if it's from 0 to a, you can write fx instead of a minus x instead of x. So those are two things you need to remember when it comes to definite integrals. We also look at the area under the curve. So area under the curve is simply get the integration of that and then have it limited by a to b. So what is fx? Fx is actually the height of y, right? So what we are doing is we're taking the height of y into dx is the let's call it the small a length here. That will give the area. Y into dx will give the area, and we are integrating. That is, we are getting the sum from a to b. We will get the entire area of the curve under the curve from a to b. So if we have two curves, right. So let's look at a past paper question on integration. So this is the 15th question from the 2016 past paper on integration. The first question they have asked us is to find the integration of dx over root 3 plus 2x minus x squared. Now, do you remember seeing anything in this particular form? Do you remember standard number method number 4? Where we had this exact form, dx over root ax squared plus bx plus c. The a was negative. So what did we do there? We arranged it in such a form that we could get the integral of sine inverse x over a. So we'll be doing the same thing here. Let's start. So they have asked us the integration of dx over root 3 minus 3 plus 2x minus x squared. Now, how do we integrate this? So we need to make it in the form of sine inverse. So what you get when you differentiate sine inverse x over a, it's in the form of root a squared minus x squared. So that's what we need to get. So how do you get it in the form of that? We need to first complete the square for this. So if we take the minus out, right, what do we get? X squared minus 2x. And if you complete the square for that, how do you complete the square? X minus, so it's minus 2x, half of the coefficient of the x, that is 1, perfect square. So this would be x squared, that is minus x squared, into this would be a minus 2x into minus plus 2x. There will also be an extra 1 square. Right? So there will be minus 1. So in order to cancel that effect, we need to add 1. So we have 3 here, plus 1 is 4, which can be written as 2 squared. Now it's in the form a squared minus x squared. So we can directly write the answer for this as dx over, sorry, we don't need to write anything actually. We can directly write the answer as sine inverse x minus 1 over 2 plus c. C is an arbitrary constant. Right? Next, what they have asked us is to find the derivative of this, and hence find the integral of x minus 1 over root 3 plus 2x minus x squared. And using the above two integrals, that is this and this, they have asked us to find this. Now, doesn't this seem very similar to standard method number 5? So what did we do there? We had something in the form of ax plus b on top, and in the bottom, root ax squared plus bx plus c, where a was negative. It's exactly this case in these two integrals. So there what we did was, we actually got the derivative of the denominator, and using that, we tried to integrate this. So that is exactly what they're trying to ask us to do here as well. So we first find the derivative, and using that, we're going to find the derivative of the numerator. Using that, we're going to find the integration. Right. So let's do. So first they have asked us to find the derivative of root 3 plus 2x minus x squared. So how do you differentiate this? So first, if you differentiate root x, you get 1 over 2 root x, right? Similarly, if you differentiate this, you get 1 over 2 root entire thing x minus x squared. And then the derivative of whatever is inside this. So if you differentiate this will be 0, 2x will become 2, minus x will be x squared will be equal minus 2x. Because we have 2 on top and bottom, we can cancel that. It will give us 1 minus x over root 3 plus 2x minus x squared. Right? That is what they're asking, the derivative of this. So what they have asked next is, using this derivative, find out what is the integral of x minus 1 over root 3 plus 2x minus x squared. Remember, they have said hence, so don't do it directly, but using this only, we need to find the answer for this. So how can I, so from the, what was the answer we got when we differentiated this? We got 1 minus x over root 3 plus 2x minus x squared. So can we actually make that in this form? We can, right? 1 minus x, if you take the minus out, it will be x minus 1. It is exactly what we need. So let's try that. Right? So how can we make this in that form? We take the minus out. So this is equal to minus 1 minus x over 3 plus 2x minus x squared. We integrate with respect to x. Now, we already found the derivative of the integral of this, right? When we differentiated 3 plus 2x minus x squared, we got this. That means the integration of the whole thing is, because we put the minus in front, we know the integration of this. That is 3 plus 2x minus x squared. Since it's an integral, indefinite integral, remember c. The c is an arbitrary constant. Right. Next part they have asked us is, so using the above two integrals, so we got two integrals, right? In Roman number 1, we had dx over root 3 plus 2x minus x squared. And then we got just now for the integration of x minus 1 over root 3 plus 2x minus x squared. So using those two, we need to get the integral of x plus 1 over 3 root 3 plus 2x minus x squared. How do we do that? So from what we have, can we get those two? They are asking us x plus 1 over root 3 plus 2x minus x squared. So we know x minus 1 is on top. We know the integration. When there is nothing on top, we know the integration. So can we write x plus 1 in this particular form? Let's try. So this can be written as, we know x minus 1, right? So it can be written as x minus 1. So to make this x plus 1, what should we do? We need to add 2 again. Right? X minus 1 plus 2 will become x plus 1. Divided by 3 plus 2x minus x squared integrated with respect to x. Now, using the integration properties, which we discussed, we can separate this into two. That is x minus 1 over root 3 plus 2x minus x squared integrated with respect to x plus integrate, what is this? 2 over this thing. But because 2 is a constant, we can just take 2 outside. Should remain dx over root 3 plus 2x minus x squared. Now, do we know the integration of these two? Yeah, right. We just found out the integration of both of these. So what was the integration of this? Was minus 3 root 3 plus 2x minus x squared. What was the integration of this? This whole thing we got as sine inverse, right? Sine inverse x minus 1 over 2. Because there was a 2 in front, let's put the 2. And for the entire thing, let's add an arbitrary constant, 6. This would be the the difference integration of x plus 1 over 3x minus 2x squared plus 2x minus x squared. So that brings us to the next question. So we have we have been asked to express 2x minus 1 and x plus over x plus 1 times x squared plus 1 in partial fractions, and hence find the integration of that. Now, even if they haven't given first this saying first get it into partial fractions and then find this, but when you see this itself, if you have integration 2x minus 1 x plus 1 over x squared plus 1 in this format, you need to first divide it into partial fractions and then do the integration. So let's try this. So the question they have given us is 2x plus 1, 2x minus 1, sorry, over x plus 1, x squared plus 1. This needs to be written in partial fractions. Fine. So how can we write this? So we need first x squared plus 1. This cannot be further factorized, right? So it should be like this. So we can have two terms, x plus 1 and x squared plus 1 as denominator, right? Now, what is the power of this? 1, right? So it's a linear term. That means what's coming on top is a constant. Let's call it a. And since this is a quadratic function, that is x squared term, that means what is coming on top would be in the form of ax plus b. Because we already use a, we call this bx plus c. So how do we get the values for a, b, and c? Let's multiply it by the denominator. That is x plus 1, x squared plus 1. That means 2x minus 1 would be equal to a times x squared plus 1 plus bx plus c times x plus 1. Did I get that? If you multiply x squared plus 1, so x plus 1 will cancel. What's remaining is x squared plus 1. If you multiply this by this term, you will get this will cancel out and x plus 1 will remain, which will be added here. So now how do we get the answer? So what we need to do is compare the coefficients. Let's compare the coefficients on both sides, the right side and the left side. So let's first compare the coefficients of x squared because we have x squared here, right? So what is the coefficient of x squared in the left side? There's no x squared term, which means the coefficient is 0. That is equal to, on the right side, we have ax squared, that is a. The coefficient of x squared is a. And we also get an x squared from here. The x times x would give you bx squared. So the coefficient of x squared in that side is b. This would be our first equation. So let's next move on to x. What is the coefficient of x on the left side? 2. What is that on the right side? So we don't get any x terms here, but we do get two x terms here. So bx into 1 will give you 1 bx, c into x will also give you cx. So we have b plus c. So b plus c is equal to 2. That is our equation number 2. So what's our next equation? We need to compare the constants. So what is the constant in this side? Minus 1. Constants in this side, a plus we have c into 1, that is c. Others will all give x terms. So have a times 1 is a and c times 1 is c. This is equation number 3. Right. We now need to find A, B, and C. And we have three equations, three unknowns, which means we can solve this. So how do you solve this? So what I'll do is I'll first maybe take the C off and get two equations for A and B, and then solve those two equations to get A and B. And then by that, we can then get C. So let's do this. So you can do it any method you want. So let's do it this way. So how do I cancel C? From 2 and 3, if I subtract 3 from 2, because we have one C here and one C here, we can this will be eliminated. We get A minus B equals something. So let's do that. So if I subtract equation number 3, equation number 3 minus equation number 2. So this would give you C and C would cancel out. A minus B would come, right? Would be equal to minus 1 minus, minus 1 minus 2, which will be minus 3. So let's call this equation number 4. Right? We have so A minus B, we have an equation. A plus B equals 0 also is another equation. So using these two, we can find the value of A and B. So what can we do? So we have plus B here, minus B here. If we add those two, they will cancel. So let's add these two. Equation number 1 plus equation number 4. Minus B plus B cancels off. A plus A will become twice A. Minus 3 on this side, 0. Minus 3 plus 0 will become minus 3. It means A is equal to minus 3 over 2. So we found out one parameter that we needed. The next one they have asked us is, we needed to find is B. So which equation can give us B? We know A. We also know that A plus B is equal to 0. So using this equation, we can find B. So from equation number 1, you can say, because 0 is equal to A plus 0 is equal to A plus B, B is equal to minus A, right? And we already know what A is minus 3 over 2, minus 3 over 2. So B is equal to 3 over 2. Right? Lastly, we need to find C. And what equation can give you C? So we know A. We know A plus B. We know B plus C is equal to 2. And we have A plus C is equal to minus 1. So I'll get the equation number 3 and try to find C. So from equation number 3, you can say that A plus C is equal to minus 1. That's what they have given. We know the value of A, right? That is minus 3 over 2. Plus C is equal to minus 1. That means C is equal to minus 1 plus 3 over 2, which would give you, so 2 times minus 1 is minus 2, plus 3 will give you 1 over 2. That is half. C is equal to half. We just found the values of A, B, and C. Now don't just write that. We need to write it. What they have asked us is, we need to find the partial fractions. So what we expressed is 2x minus 1 over x plus 1 times x squared plus 1. We expressed it in these terms. A over x plus 1 plus bx plus c over x squared plus 1. Now we know A, we know B, we know C. We just have to substitute. So the answer, final answer would be 2x minus 1 over x squared plus 1, sorry, x plus 1 times x squared plus 1 is equal to, what is 8 minus 3 over 2 times divided by x plus 1 plus, what is B, 3 over 2 times x plus, what is C, half divided by x squared plus 1. That's what they have asked. Express this in terms of partial fractions. Now the next thing they have asked us is to find the integration. Let's go back to the question. They've asked us to find the integration of 2x minus 1 over this, so which is what we exactly found the partial fractions for. They have asked us to find the integration of this, which means we have, now it's very easy because we know the partial fractions. Now since we know this, so this is what we found, we can also write the integration of 2x minus 1, that is what they have asked us, x plus 1 times x squared plus 1 can be written as partial fractions. So minus 3 over 2 is a constant. So I'll take minus 3 over 2 both side. Okay, we are integrating it with respect to x. So what's remaining here? Nothing on top. That means let's put dx over x plus 1, right? Plus, and because 3 over 2 is there, half is there, I'll just take half out. So this makes it easier. What do we have on top? 3x plus 1 divided by what's it on the bottom? X squared plus 1. Correct? And we integrate it with respect to, sorry, x. This should be dx here. So we can now, do we know the integration of this? So x plus 1, if we differentiate it, we get 1. Now, if you remember what we discussed before, if you have anything in the form of f dash x over fx, that means the derivative of the denominator is on the numerator. So then we can write it in the form of ln, whatever is in the denominator. So if we differentiate x plus 1, we get 1. This is what is on the denominator. So we can write this as the integration of this as ln x plus 1. And here, what is this? If we differentiate this, we get 2x, but what's on top is 3x plus 1. So can we write this in the form of 2x? Let's do it. So we can write the same thing as 3, because we already know the differentiation of dx over x plus 1. I'll keep it like that. And what we need to make is make the other one in the form of 2x. So we can write, because it was 3x plus 1, we can even further break that as well. We can break that as, I'll take the 3 outside. So we can have x here over x squared plus 1 dx. And I'll take the plus 1. No, earlier we had 3x plus 1, right? So I'll take it into another term. That is plus 1, because there's still a half here, plus 1, or you can just put it as dx over x squared plus 1. Now, do we know the integration of this now? So what I did here was, we initially had 3x plus 1 on top. So I took 3x as a separate term and plus 1 as a separate term. Because 3 is a constant, I took it out. So that's why 3 came here. And the same thing half applies to this. Now, do we know the integration of this? So this we know ln, but this, now if you differentiate this, we get 2x, right? So if you differentiate the denominator, you get 2x. So let's make this 2x. So because I put 2 here, to cancel that off, I put 2 in bottom. Now, do we know the integration of this? So what is the differentiation of tan inverse x? 1 over 1 plus x squared, right? This is exactly what we have here. So we can write this as the integration of this as tan inverse x, correct? We know all three integrations, so let's write the answer. The answer is equal to minus 3 over 2 ln x plus 1. Remember, this is modulus, plus this is 3 over 4 times ln x squared plus 1 plus tan inverse x. Okay, I put half tan inverse x. Whole thing is an indefinite integral. So remember, let's see, it is an arbitrary constant, right? So what we did was, we initially converted in partial fractions, and using partial fractions, we divided the whole thing so that we can find out the integration of 2x minus 1 over x plus 1 into x squared, which is what we just found out. Right, now let's look at question C. So in the first thing, they have asked if n is not equal to minus 1, we need to find the integration of x to the power n times ln x using integration by parts. Now, if you remember when we discussed about integration by parts, the formula was, if you had two things, multiple of two things, that is u and dv by dx, if you integrate it, we can write that as uv minus v times minus the integration of d times du by dx. So that is the formula for integration by parts. And the most important thing there is we need to select what is u and what is dv by dx. So in this case, we have two things as well, x to the power n and ln x. So we need to select which would be u and which would be dv by dx. So let's see. Question is, integration x to the power n x is n is not equal to -1. Integrating with respect to x, right? So what in this can be taken as u and what can be taken as dv by dx. So let's see. So if we differentiated the ln x, the answer would be 1 over x. If we integrated this, that would be a bit difficult, right? But if we take the integration of this, that is dv by dx, and the differentiation of this u, and you ln x, the differential would be, derivative would be 1 over x. So 1 over x would cancel with this as well, right? And we can also take the integration of this. So it's better if we can take this as u, this as dv by dx. So before applying the formula, I'll just write in the side. So what v is equal to ln x. That means du by dx would be, if you differentiate this, you get 1 over x. And x to the power n is equal to what? dv by dx, which means v is equal to integration of that x to the power n plus 1 divided by n plus 1. Right. What was the equation again for integration by parts? If we have u dv by dx, that can be written as uv minus integration v dv by dx. That was the formula talked for integration by parts. So let's try to use that in this. So we have u, we have dv by dx. This can be written as uv. What is u? ln x. What is v? The integration of this, that is x to the power n plus 1 divided by n plus 1 minus integration v du by dx. What is v? X to the power n plus 1 divided by n plus 1. That is v du by dx. What is du by dx? So u is ln x. So we just found du by dx is 1 of x. So this, that's what's okay. This part can be simplified. So we have x to the power n plus 1 and we have x. We can cancel this and set put n. So we have x over n plus 1. So n plus 1 is a constant, we can take it out. So what's remaining here is x to the power n. So what is the integration of x to the power n? We did it just before, right? So it can be written as x to the power n plus 1 divided by n plus 1. Let's try the whole thing. I'll write this first, that is ln x to the power n plus 1 divided by n plus 1 minus, what is this? We already have an n plus 1, so it will be 1 over n plus 1 outside. Now when you integrate this, it will be x to the power n plus 1 divided by n plus 1. But since we already have an n plus 1, that n plus 1 and this n plus 1 will be multiplied. We can write both as n plus 1 square. Since this is an indefinite integral, we need to add plus c. Plus c is an arbitrary constant. Right? So that's the answer for this question. So what did we do? We first, when they say by parts, we need to make sure the equation is, if we have u dv by dx, the equation is that can be written as uv minus v dv by dx. So we need to find, first of all, which of this is u and which of this is dv by dx. So see, when we differentiate this, it will be easier to simplify this other one. So we take this, we took this as u and this is dv by dx. By simplifying, we finally got the answer as such. Right. Next, what they're asking is, they have asked us to evaluate ln x over x. From 1 to 3, which is a definite integral dx. Now, how do we integrate this? Now, you might be tempted to use the one we just proved before on top. Can we do that? And let's see, I'll just write this separately so that you can see it. So this is what they're asking us to do. So if we separate this, we can write this ln x 1 over x, right? This can be written as 1 3 ln x into 1 over x. We have two things here. One, and what is 1 over x? X to the power minus 1. So above, what did we prove? If you have x to the power something n, ln x dx, then the answer is this. So you might be tempted to use this formula and use the thing. But if you look at the question, you will see that it says when we did the integration by parts, that's valid only when n is not equal to -1. So we can't use that. So what else can we do then? Now look at the format of the question. So we have got it as ln x into 1 over x. What is 1 over x? What do we get when we differentiate ln x? 1 over x, right? So can we, like, is there any way we get something like this and then the derivative of that? Do you remember the chain rule? So for example, if we have something like, say, sine x squared, I was going to differentiate this. What would be the answer? First of all, I would take 2 in front and put sine x itself. Then I would multiply this by the derivative of what's inside. What is inside? Sine x. What is the derivative of sine x? Cos x. Right? So look at this. We got the constant in front and we got the same thing here. And then we got the derivative of this in multiplied by. So isn't this very similar to what we have here? We have something here and the derivative of that next to it. So let's just say if we have ln x squared, what would be the answer? If I differentiate this, ln x squared would give you twice ln x into, then we need to get the derivative of ln x. That is 1 over x. Isn't that almost what we have here? So we can use this formula. So because there's an extra 2, we can cancel that out and instead write this as half ln x to f(x) squared. Right? Now, we can't just leave it at that because they have given us a definite integral. That means 1 to 3. We need to substitute these values and get an answer. So how do we substitute? We can directly say this, write it in the next slide. I can write that half. This was what we had, ln x squared, the whole thing from 1 to 3. This can be written as half ln. You can take the half outside, so it's ln 3 the perfect square minus ln 1 the perfect square. What is ln 1? Logarithm of 1 of anything is 0. So we can directly say this is equal to half ln 3 square. Do we put a plus c here? No, because this is a definite integral. Right? Right. Let's next look at another past paper question. This is the question from 2020 paper. So here, this is the first part question. So if you remember, what the last thing we discussed was on volume of revolution, right? And this is what they have said. So they have there's a region that is enclosed by the curve. So they have given us the equation of the curve, and this curve is rotated around the x-axis. So when this curve is rotated around x-axis, a volume is needed, right? So we are asked to find the volume of this solid is generated. Sorry. So we are asked to find the volume of this solid that is generated, and they are asking us this volume should be from x equals 0 to x equals ln 3. They have also given us the answer. We need to prove that this is the answer. So how do we do this? So it's very simple. If you remember, you just have to remember that equation for the volume of the solid generated by rotating a region around the x-axis. And if you can remember, it was phi integration fx squared. And we integrated it from a certain limit. The limits they have given. For example, in this, it's 0 to 3. Okay. So let's try this. So if you can remember the equation for the volume generated was, volume would be 5 times integration fx. This is the curve that is being rotated, the perfect square, and we integrate this with respect to x. So if you can remember, what we said was, it's very similar to a small piece of, so we take pi r square, that is the area, and dx, a very small length of the plate, that will give you a very small volume, and we differentiate, or sorry, integrate it from the region we want. In this case, they have set from 0 to ln3, and then we will get the total volume, right? So what is fx here? So in this case, they have given fx as e to the power x over 1 plus x. So this is the general formula for any function. So for this, we'll write it. So it's ab are the limits. So for this, let's get from 0 to ln3. What is the equation? E to the power x over 1 plus e to the power x. The perfect square. We can further write it as pi into 0 to ln3. So e to the power x is x squared is, you can multiply this too. That means e to the power 2x over 1 plus e to the power x, the perfect square. Integration with respect to x. Now, even if you don't know how to integrate this, write this, because there are also marks, 5 marks given for just writing this equation. Right? You haven't integrated done anything, but write this. So now we need to integrate this. So can you think of any way that you can integrate this? Now, if you look the bot or the denominator is a bit complicated. So we have a square and we have a lot of terms. So it's very difficult to separate this into like individual things that we integrate, right? And but what if, like, instead of a lot of values, what if there was just a single value in the bottom? Then it would be a bit more easier to integrate. So for this, what we can do is we can use a substitution. So in this case, there's no standard substitution. So we need to think and apply a substitution. So the substitution I'm going to do is, let's look at the denominator. What does it say? 1 plus e to the power x. So let's use that substitute as the substitution. 1, let's say t is equal to 1 plus e to the power x. So if t is 1 plus e to the power x, 1 plus e to the power x, what is e to the power x? E to the power x is t minus 1. Now we can't just take this and substitute where we have this, but we also need to differentiate this and get dx. So we need dx in terms of dt and x. So if you differentiate this, you get dt by dx is equal to e to the power x. 1 is a constant, so that's it. So if you so what is dx? Okay, now dx would be dt over e to the power x. Dx will be dt over e to the power x. Now we can't write dx in terms of x again, right? We need to make this as well in the form t format. So we know what is e to the power x, t minus 1. This can be written as dt over t minus 1. That is dx. Now there's also something else we need to consider when we are doing substitution for definite integrals. So definite integral is something that has limits, right? 0 to ln3. So whenever you have a substitution for limits, you need to also substitute those and find out what are the specific limits that come after the substitution. So in this case, what they have given, what are the limits they have given? 0 and ln3. What is 0 and ln3? They're integrating with respect to x, right? So x is equal to 0. So x is equal to 0. When x is equal to 0, what do we need? T is equal to 1 plus e to the power x. What is e to the power x? E to the power x is equal to 0. E to the power 0 is equal to 1. So that means when x is equal to 0, t is equal to 1 plus 1, that is 2. This is the first limit. The lower limit would be 2. And the next limit, or the upper limit, is x is equal to ln3. When x is equal to ln3, that means e to the power, we need 1 plus e to the power x, right? So what is e to the power ln3? So ln means logarithm to the base e, right? So this would simply be 3. So if you want to verify how that came, you can just put e to the power ln3, it's called y. Now by the definition of logarithm, if we have something to the power of this thing, so the definition, or so the logarithm of y to the base e, that's what ln means. would be the power of this, right? ln 3. We have logarithm on both sides. That means y is equal to 3. What is y? E to the power ln 3. That is 3. So we know x is equal to ln 3. When x is equal to ln 3, e to the power ln 3 is 3. So we need t. T is equal to 1 plus this value. That means t is equal to 4. So now the new limits are not 0 to ln 3, but 2 to 4. So we have done everything we need. We have made a substitution. T is equal to 1 plus x, 1 plus e to the power x, and we got e to the power x in terms of t, and we also got dx in terms of t, and then we finally change the limits to what we need. So let's move on to the next part. We are going to substitute, make the substitutions in the original question we have given. So it was, the volume would be, now it's 5. What's the limit? It's from 2 to 4 this time. And what is on the bottom? So what the substitution will be 1 plus e to the power x is equal to t. So we have t squared in the bottom. What's on top? E to the power 2x. What is what is e to the power x? That is t minus 1. So what is e to the power 2x? That is simply e to the power x, the perfect square, right? So e to the power x we know is t minus 1. That means e to the power 2x is t minus 1, the perfect square. We are integrating with respect to x. So that means dx. So now we converted that into t. So what is dx in terms of t? We found that as well. That was dt by t minus 1. Right? Now we made the total substitution. So what are the different simplifications we can make? We have t minus 1 here, t minus 1 squared here. So we can cancel these two out. And we can separate these two. So t over t squared can be written as 1 over t. 1 over t squared can be written as 1 over t. Now, see, now there's only one term in the denominator. So it's easy to separate these two terms as two separate terms. It's 5, 2 to 4. T over t squared will be 1 over t minus 1 over t squared. Integrate with respect to t. So what is the answer for this? Now can we integrate it? It's much more easier. So 1 over t, that's simple, right? ln. If you have 1 over x, if you integrate 1 over x, the answer is ln x. Similarly, if you integrate 1 over t with respect to t, it's ln t. So what about the other one? 1 over t squared. But if you remember, if you have 1 over x, for example, and if you had to differentiate this, what would be the answer? 1 over x is simply x to the power minus 1. So if you differentiated this, that will become minus 1 will come in front, that is minus x, and subtract 1, that is x minus 2, that is or 1 over x squared. So if you differentiate 1 over x, you get minus 1 over x squared. So similarly, if you differentiate, what do you get? Minus 1 over t squared. 1 over t, right? So let's try that. Similarly, minus 1 over t squared, if we the integrated, it will be 1 over t. So the answer would be 5 times. This would be ln t minus, not minus this time, 1 over plus 1 over t. Because if you differentiate this, you get minus 1 over t squared. Right. Now this is a definite integral, which means we need to substitute the values 2 and 4. This can be written as 5 times, what is ln 4? So just write it, ln 4 plus 1 over 4 minus ln 4, ln 2, sorry, the lower limit, minus plus 1 over 2. So can we do this? Now, if you take these two, you know that if you have logarithms minus logarithms, we can actually divide them, right? This can be written as 5 times ln 4 divided by 2. 4, this is because it's minus. 4 divided by 2 is 2. So this can be written as ln 2. Plus, now we have 1 over 4 minus 1 over minus half, which is if you multiply both by 2, that is 2, 2. So 1 minus 2 is minus 1, and the denominator will be 4, that is minus 1 over 4. Right? So next what they have asked us, what we need to do is to look at the question. So is this the answer we need, or is it something else? Right. If you look at the question, you see it's in the, it's almost same, but it's in a different format. They have asked 5 divided by 4, 4 ln2 minus 1. So let's take this. So if we take 1 over 4 outside, so it's 1 over 4 here, right? So well, let's take that out. We get 5 divided by 4. So if you take 4 outside, you need to multiply this by 4. You get 4 ln2 minus, you do minus 1 over 4 outside, which is the answer that they have for 5 by 4, 4 ln2 minus 1. 5 by 4, 4 ln2 minus 1. Right. So what did we do? First of all, what they asked us was the volume. They asked us for the volume of the solid generator. And we knew the equation for this 5 fx square from a to b. That's the general equation. And we substituted and we got this. This was a bit difficult to integrate. So what we did was we made a substitution. 1 plus x is equal to 2. And necessary when we did that, we got dx in terms of dt, and we also got the limits in terms of t. Having done that, we made the particular substitutions, and we got the answer as this 5 ln t. Because this was a definite integral, we used the upper limit and subtracted that from the lower limit. Finally, we got this answer, and finally in the form of the answer that they require. This brings us to the end of today's session. Thank you, and over to you.